All right, yeah, go ahead and write out the whole equation here. How many feet is it if you're playing catcher and you're throwing the ball down to second? Don't yell it out yet. Everybody solve it. Do it mathematically. Who can give us a hint right off the bat? What are we going to need?
I don't have paper. Diagram paper.
Okay, we'll get you one. Missy, you have another paper? What is it? If we have a triangle, break it up into a triangle with a 90-degree angle right here. What can we solve using with the triangle with a 90-degree angle? Which theorem? Pythagorean theorem. So let's start from there. Anybody watch the open tonight with the Reds? I don't even know if they won. You guys Reds fans? They lost? So also on a baseball diamond, it's 90 feet to here. It's also 90 feet from first to second base.
127.
Oh. Don't yell it out yet. I'll let you go out there and solve it. Let me say it. Are you sitting in your calculator?
That is okay.
You guys, most likely, you'll definitely have a couple of Pythagorean theorems on the ACT coming up. And they might even word one similar to this, where it's a scenario, maybe it's on a basketball court, and you're passing it, you're doing a half-court press or something, and you're trying to pass it across in different angles. Use it. How you doing, man? Who saw that injury the other night, the Louisville injury? Pretty sick, wasn't it? It actually, if you notice, he wasn't even in that much pain on the ground. It just looked nasty. When you break a bone, so say this is your bone, you're looking down on it, it's only thick so far. All this in here is just bone marrow. So if you snap a bone completely in half, all your nerve endings just get cut right in half. So it's actually not as painful as a little hairline fracture down the side because your nerve endings are still trying to fire. So it looked really bad though. Coach Patino, man, he was about out to the three-point line there. So let's get this one done so we'll get to the worksheet. Pythagorean theorem. Let's see how you said it. 90 squared. Good. What's Pythagorean theorem?
A squared plus B squared.
A squared plus B squared equals C squared. So our C is the hypotenuse, our long side right here. So let's go ahead and plug in this for our A, for our B. 90 squared plus 90 squared equals C squared. What's 9 squared right off the bat? What's 9 squared? 9 times 9, 81. So 90 times 90, we're just going to add the 2 extra zeros. 8100 plus 8100 equals C squared. What's 81 plus 81? Do it in head.
162.
162. Good. The extra zero, so that's going to be 16,200. All right, so what's the opposite of squaring a number, Dave? What's the opposite of squaring a number? Square root. So let's square root this number right here. Who got square root of 16,200?
127.
127. What was the decimal on that? Let's take it to the hundreds.
0.27.
0.27? 28, we round it up. That's in feet. So 127 and 2,800 feet. You go from home plate to second base. Home plate has 5 sides. What do we call that? What kind of pentagon? Pentagon. Nice. Who plays softball in here? Yeah, softball. What is it from home plate to first? 60 feet? It's 60 feet. It's 45 for the mound. I have to umpire 3 softball games actually on Saturday. So, all right, let's get on to this packet we're on. I'll go through the first 3, and then we're going to have you guys get up here and solve them together. So, watch out for those, though, on the ACT. Just always be thinking if you see right angles with triangles using the Pythagorean theorem. Read this math book. Pythagorean, they said, actually wasn't just one guy. It was a group of people. It was the Pythagoreans. So keep that in your memory in case you need it later for some Jeopardy.
Oh yeah.
Oh, you, oh yeah? Just oh yeah? Should have oh you. Oh yeah. All right, Michelle is making goodie bags for Christmas filled with chocolate candy. Chocolates cost $2.50 per pound and candy costs $3 per pound. So we want to write an equation showing that Michelle spent a total of $40 on chocolates and candy. So since we have chocolates and candy, they're both C's, we want to have two separate variables on that. You can use any letter you want, but let's go. We all have $2.50. Then which variable? You want to use C for the first one for chocolate. So let's do a kind of a bigger C. Plus then $3 for the candy. Tia, what do you want to use for that variable?
T.
T. All right. If you ever use a T and we're using addition, be careful. Just put a little swoop on it so that you don't get it confused later on. And that's going to equal $40 for the amounts. So these are all dollar amounts right here. The $3 and the $2.50. This is letter A. All right. Get that written down. So we're just using our variables in here with chocolates, and then this was candy, but we're using T just to keep them separate. And then $2.50 multiplied by the amount of chocolates added to $3 times the amount of candy for the first one, but we haven't had a second equation yet to solve for each of them. So let's write an equation showing that Michelle bought a total of 15 pounds of chocolate. So our pounds are our C and our T. So how do you think we would write that out? An idea? You have an idea? Well, we're just going to combine it with addition.
Yeah.
So just do the C plus the T is going to give us 15. And then it's in pounds right there. So now we have two equations with the same variables, and we can put them together. There's two ways we can do it. Either we can substitute one variable in and solve it that way, or we can do it by simplification and canceling out some of the numbers. But let's do it with substitution, since we have just variables one by themselves with no numbers in front. So let's go ahead and get C by itself. We'll solve it for letter C now. But the first thing let's do is let's get this C by itself over here. So C equals, what's it going to equal?
15 minus T.
Good. 15 minus T. Because we're adding T, so we subtract it. Subtract the T over here. Ms. Szink and I, we were talking earlier actually. I never heard this until when I was student teaching. If you actually put a line down the middle, they said if you're trying to just jump that fence to the other side, just use the opposite symbol. But you guys have been doing one-step and two-step equations for a long time. You guys understand. Do the opposite and bring it over. But just in case you get mixed up, it's kind of an easy way to remember. So now we have the C here by itself with the second equation. So we can actually plug this or substitute it right back in to the top equation. All right, so since we have C, so we're going to have then 250 parentheses. Since we have C equal to all this, we're going to just take this whole chunk and just insert it where that C was. And we're going to put it right here. So it'll be 15 minus T plus, then this is all still the same, 3, and we have a T equals $40. So now we have all these T's together. What we're trying to get to is having all the same variable in the equation, so then we can combine like terms and solve it through. So, what's our next step going to be? What would you go from here? Parentheses. What are we going to do?
Distribute.
Distribute. Good. So let's distribute it to each one of these. What's 250 times 15? Who can do it in their head? What's 2 times 15? 30. What is a half of 15? 7.5. So 30 plus 7.5 is? 37.5 minus, make sure too, we have a positive 250 multiplying to a negative T, essentially. So we're going to have minus 250